Good morning. In this video, we will discuss some more exercises on computer performance. We already discussed this exercise, which is shown here. Like in case if you have given the instruction count and then the CPA and then the clock cycle time, you can easily calculate the execution time, CPU execution time. Instead of clock cycle time, if you are given the rate, I mean the frequency, clock rate or the frequency, you can able, this is the formula. Can you see? Instruction count multiplication CPI divided by the clock rate. You already know that there is a reciprocal relationship between the clock cycle time and the clock rate. That is the clock period and the clock rate. Okay, fine. So in case, let's see one other exercise. Can you see this exercise? We already discussed this exercise in the class. Number of instructions. The total number of instruction is given and the CPI is given. CPI for the whole program. Can you see? Average CPI for the whole program. For the entire program, this is the CPI. What is it? 4 cycles per instruction. And then the clock rate of that machine is also given. Now the question is calculate the CPU execution time. We now know the formula. Instruction count multiplication the CPI for the whole program divided by the clock rate. So you will get the execution time in seconds. Okay. Can you look at this exercise? Instruction of a program. The total number of instruction is given 100,000. And then the CPI of the whole program. Everything is given for the whole program. The program contains this many instruction and the CPI of the entire program is 4 cycles per instruction. This is the details given. In case if the given details are too specific, like this way, how will be the calculation? So what is the too specific? So here in this exercise, can you see here? Let me make it little bigger. Yeah. What is the two specific details? Here, when you see that this is not talking about the entire program, they talk about parts of the program, sections of the program. Okay, for example, here is program 1, code sequence means program 1. It contains 2 instructions of this type. This type may be a load instruction. 1 instruction of type B, this type of instruction, and 2 instruction of this type. So totally there are 5 instruction in program. Totally how many instruction in program 1? 5 instruction. 2 plus 1 plus 2. How about the program 2? Another program. Okay, different program. Not the same program, different program. It has 4 instructions of this type of instruction. This type means A type of instruction, like load instruction maybe. And 1 instruction of this type and 1 instruction of C type. So totally 4 plus 1 plus 1, 6. So this is the total number of instruction. They don't give total number of instructions, but they give details. Like it has this many instruction of this type, of this type, of this type. Like 2 add instruction, 2 subtract instruction, 5 multiplication instruction, something like that. Details. Okay. Can you see the above table? The CPI is given in the above table. CPI. The CPI is not for the entire program. CPI is for this type of instruction. A type of instruction means the CPI is 1. For B type of instruction, CPI is 2, some number different. For C type of instruction, the CPI is something. So, can you see the difference between the previous program? In the previous program, the total number of instruction is given. Can you see? Where is it? The total number of instruction is given. How many instructions are in one program? 100,000. What is the CPI of the entire program? 4 cycles per instruction. So this is talking about the entire, the whole program. But now what I'm talking is, it's not about the whole program. It's about the details of each program. Okay. The program contains this many instruction of this type. This many instruction of another type. this many instruction of another type. Every type its own CPI. Okay. So first of all, what you need to do is, there are many questions the program asks. Okay. So let's see what are we solving. Okay, let's see what are we solving. Okay, this is the question. It's written here. Can you see this paragraph is talking about the question? Which code sequence is faster? What is the CPI, etc., etc. So this paragraph is talking about the question. Which code sequence executes most instruction? That is can you see the first program has 5 instruction, second program has 6 instruction. Okay, first program has 5 instruction, second program has 6 instruction. So which one is having fewer instruction? Program 1. Okay, that is the one the first question asking. Okay, ignore it. That's not a big deal. Now let's look into the which will be faster. Okay, let me decide which will be faster. In order to find faster, I cannot calculate the CPU execution time because I don't know the clock rate. The question doesn't talk about the clock rate. The question doesn't say anything about clock rate or clock cycle time, the period. The details of the period is not given. Details of the clock rate is not given because, can you see the formula? If you want to, can you see the formula? If I want to calculate the size, I should know the instruction count. I have CPI, I can able to find out. Clock rate, I don't have clock rate. Another formula, this formula, can you see this formula? Instruction count, CPI, clock cycle time. I don't have the clock cycle time. So what can I do? I can calculate the cycles. Okay, based on the cycle, I can tell you that which one is faster. What is the clock cycle, instruction count and cycles per instruction. This one. Instruction count and this CPI. That is given. Is it? Instruction count is given, CPI for the instruction is given. So use those things and calculate the cycles. Okay. So let me calculate the cycles. Now you need to know, for calculating the cycle, I say instruction count multiplication CPI. But can you see there is 2 instruction of A type, 1 instruction of B type, 2 instruction of C type, and this is the CPI on the top is given. So what will be, how can we calculate? So here it is the formula. Summation of CPI multiplication count for every type of instruction. We have 3 type of instruction, is it? So for every type of instruction. So let's see. So I'm going to calculate the CPU cycles. CPU cycles for computer program 1. I write 1 because there are 2 programs, program 1, program 2. So first thing what to do, CPI multiplication count. So I have type A, type B, type C. Let's do one by one. Type A. CPI is 1, count is 2, plus summation of all those things, is it? Okay. Okay. And then type B. CPI count is 1. Can you see where I am getting? I am getting from here. CPI is 2, count is 1. Plus third type C. CPI is 3. Okay, bracket. Put a bracket. CPI is 3. I'm talking about this type 3 and the count is 2. Okay then. Now you need to multiply and then add. 1 into 2 is 2 plus 2 into 1 is 2 plus 3 into 2 is 6. When I add them all, I get 10 cycles. This is for the first one. You got the idea what I am doing? Okay, let me do the second one. What do you mean by second? I did the CPU cycles for the program 1. Let's do the CPU cycles for program 2. The same thing. What you do? Summation of CPI and the count. This is the question. Summation of CPI and the count. So CPI for the type A 1. Count. Look into this program 2. It has 4 instruction. Plus type B CPI is 2. And then how many instruction? 1 instruction. Plus now I'm going for the type 3. Type C. CPI is 3. How many instructions are there for type C? 1 instruction. So when I add them all, multiply and add them. 4 into 1. 4 plus 2 plus 3 equals, I guess I'm getting 9 cycles. Okay then. I'm writing the unit. You see this unit? Okay, let me put it little down. Let me change the color. Okay. So the first one I'm talking about the CPU cycles. The second cycles for the program 1 and the second I'm doing for the program 2. You can compare in the side. See, the calculation is written here. I'm getting the same answer. Okay, fine. Now, by seeing the number of cycle, you can conclude which program is fast. The question is, which will be faster? Can you see 10 cycles, 9 cycles? Obviously, 9 cycle is shorter. Shorter the cycle, faster the performance. Okay, so program 2 is faster. You need to look into this one. Program 2 contains 6 instructions. Program 1 contains only 5 instructions, but still program 1 takes more time because the CPI. Can you get the idea? Okay. Now, the question is asking what is the CPI for each sequence. The CPI for class A, class B, class C is given, but the entire program, CPI of the entire program, the whole program. So, CPI of the whole program. What is the formula? Here is the formula. CPI for the whole program. Okay then. I'm talking about what is the CPI of program 1, what is the CPI of program 2. This is what I am asking. Okay, so the formula is given. Let's do it. So, CPI of program 1 is equivalent to, very simple, cycles divided by total number of instruction. What is the cycle? Just now you calculated 10. Total number of instruction, just now I calculated here 5. That is equivalent to 2. Okay, fine. Now let me do the other one. This is CPI of program 2. Let's do the program 2. Okay. Yeah, CPI of program 2. What is the formula? Formula is number of cycles divided by the total number of instruction. Just now we calculated the cycle. Total number of instruction is 6. So when you divide, you will get 1.5. Is it fine, everybody? Clear? The blue color one is for program 2. The black color one is for the program 1. So this is what the question is asking. Okay, the question here. Can you see the question? Okay. Which program is faster? I told you program 2 is faster because it takes less number of cycles. Okay, and then I'm asking this CPI of program 1. What is the CPI? What is the CPI of program 2? Okay, don't get confused with this table. This table talks about CPI of the entire program. I'm not asking the entire program. Sorry. This table is talking about CPI of the type of instruction, okay? But the question is CPI of the entire program, okay? CPI of the entire program, okay, fine. So this is the idea. In case, if the question is asking, the question doesn't ask, let's look into another question so that I can say something. Here is another question. The same type of program, okay, but different way of asking. Can you see here? The clock rate is given here because we have two programs. I'm going to run on a particular machine. That means only one computer I have. And then the clock rate is given. And can you see? First program, it has 7 instructions. Okay. So what to do here? You need to figure out. First thing is, do one thing. In the previous exercise, we had a table. That way of table is clear for me. So I'm going to do a table. Okay, let's continue. I made a table here by seeing this question. What is the question says? You have 3 groups of instructions, group A, group B, group C. I made a table here. And then the CPI is given here, 2, 1, 2 cycles per instruction respectively. 2, 1, 2. For group A 2, group B 1, group C 2, something like that. Okay. Program 1 has 7 instructions. Okay, what are the 7 instructions? 3 of A, 3 of B, 1 of C. Can you see? 3 of A, 3 of B, 1 of C. So totally how many instructions? 7. Program 2 has 9 instructions. What are they? 2 of A, 3 of B, 4 of C. 2, 3, 4. 2, 3, 4. So how many? 9 instructions. You got the idea? So the given information, I put it in a tabular form. So it will be easy for me to calculate. Okay, fine. Now the question say calculate the CPU cycles. You already know the CPU cycles. How to calculate? How to calculate that? Sum of CPI into count. You remember the formula? Now same thing we do. We are going to calculate the cycles for program 1. The same formula, CPI into count. First A type is 2, CPI count is 3. Plus I'm doing the B type, 1 into 3. Now I'm doing the C type, 2 into C type, 2 into 1. Now calculate the multiplication and summation. 2 3s are 6, 1 3s are 3, 2 1 is 2, which is equivalent to 11 cycles. So I finish with my first calculation. Now I'm doing the second. What is the second? Cycles for program 2. Again, what is the formula? Summation of CPI into the count. Okay, so CPI for A is 2, count for A is 2, plus CPI of B is 1, count for B is 3, plus CPI of C is 2, count 4. Let's multiply. 2 2s are 4, 1 3 is 3, 2 4s are 8, which is equivalent to 15 cycles. Okay then, so we calculated the CPI clock cycles for program 1 and program 2. Now the question asks you calculate the CPU time. Yeah, here comes the second question, CPU time. When you want to calculate the CPU time, do you remember formula for CPU time? Let's go to the other. Where is it? No, not this one. Yeah, here it is. Can you see here? If you want to know the CPU time, this one, instruction count, this one is the cycles. We just calculated the cycle. Can you see instruction count CPI? This one. What is this one? This is clock cycle. We already calculated. We know it. Multiply that number with the cycle time. If you have cycle time. We don't have cycle time. We have clock rate. So, divide. Okay. This one, instruction count in CPI. Just now we multiply something. That is the cycles. We already calculated the cycles. Divide by clock rate. That's it. You got the idea? So, just divide by clock rate. So, where is my question? It's here. Yeah, let me move it. Yes. So, we now calculate the CPU time. Okay, let's calculate the CPU time. CPU time for program 1. What I said, cycles divided by the rate. This is the formula. Cycles divided by the rate, clock rate. Okay, fine. What is the cycles? 11 cycles. Clock rate is what? Question gave some rate. 40 megahertz. 40. Okay, wait a second. 40 mega. Mega means what? 10 power 9. Sorry, 10 power 6. Mega means 10 power 6. Giga means 10 power 9. Okay then. So when you do some kind of calculations, you will end up, wait a second. Let me put it 0.275 times, because the 10 power 6, let me put it on the top, so it comes -6. Is it fine? So this is the CPU time. Very simple. You divide the cycles by the rate. How to calculate the cycle? You know already. Okay, fine. So now let's calculate the CPU time for program 2. So CPU time for program 2 is equivalent to, as I say, the formula is cycles divided by the rate. The cycle is what? The cycle is, just now we calculated the cycle, 15 cycle, divided by the rate is 40 mega means multiply by this multiplication. Okay, 10 power mega means 6. So that is equivalent to 15 divided by 40. So let's say it's 375. The 10 power 6, when it goes up to the numerator, it will become -6. That's it. Seconds. You need to write the unit. Unit is too important. Okay, then without unit, it will be very different. Okay, then. So try to write the unit. Let me put blue color for the program 2 and then black color for the other one. Okay then. So let me get bigger, smaller, so you can see it. Okay, fine. So now this is the second question. Calculate the CPU time. How about the CPI for each program? The third question is asking CPI. Can you see the third question? CPI for each program. So CPI. What do you mean by CPI? In the previous exercise, I told you the CPI. Very simple. The clock cycles divided by the count. Very simple. How many instructions are there? So let's do the third question. So the third question is CPI for program 1. The formula is cycles divided by the instruction count. I write IC. IC means instruction count. How many cycles? How many instructions? You all given in the question. You get the idea? Cycles you calculated few minutes ago. The number of instruction, it's there. Can you see that? You calculated just now. 3 plus 3 plus 1. 7. So, when you divide by 7, let me put one decimal is enough. 5, 7 becomes a 6. Okay, this is the CPI. Let's do for program 2. So, CPI for program 2. So, I say cycles divided by instruction count. Just now you calculated the cycle. Instruction count is 9, which is equivalent to I maintain one single digit. It comes like 1.66. I make it one single digit, 1.77, something like that. So, your question is asking too many things. Okay, this is your question. So, the question gave you the rate and it gives the details about 2 programs. I put a table because the question is paragraph type of question. Better I see the details in a table, I can easily understand. So what the paragraph says, the program contains 3 type of instruction. A, B, C. Type A, type B, type C. The CPI of each type is given. For program 1, how many instructions are there for these 3 types? So totally there is 7 instructions. For program 2, how many type of instructions are there? And totally we have 9 instructions for program 2. Now the question asks, calculate the CPU cycles. There is a formula for calculating the CPU cycles here. CPI into count plus CPI into count plus CPI plus CPI into count plus CPI into count, something like that. So when I calculate, I get 11 cycles for program 1, 15 cycles for program 2. And then question asked me to calculate CPU time. Very simple. Cycles divided by the rate. Or if you are given period, cycles multiplication period. Here the question gave me the rate. When you see something in heads, it is a rate. The question didn't say this is clock rate. Is there any way? The question say particular machine with 40 megahertz. Heads means it is rate. So the formula is the cycles divided by the rate. Just now you calculated the cycle and then the rate. Rate is in 40 megahertz. Mega means 10 power 6. So I am dividing. So that 10 power 6 go up numerator. So it becomes 10 power minus 6. And the unit is seconds. So I do the same thing for program 2. And the question asked me calculate the CPI. Very simple. CPI means cycle divided by the total number of instruction. Instruction count. IC. Instruction count. How many instruction count? For program 1, there are 7 instruction. For program 2, there is 9 instruction. Okay. So, you multiply this. Okay, I told you blue color for program 2 and then black color for program 1. So, this is the calculations. Okay, fine. So, if you understand this calculation, wait a second. It's here. There is a question. So this is another question similar to the previous one. Can you see there is a clock is given. This is clock rate 20 megahertz. The question already put everything in tabular form. Easy for you. The previous question I said type A, type B, type C. Here they say load, add, move. It's okay, whatever. And CPI is given instruction count. For program A, program B, this is 2 instructions of load type, 1 instruction of add type, 2 instruction of move type. So now calculate the CPU cycles, calculate the CPU time, and then the CPI for the entire program, for program A and for program B. Same like before. I hope you can able to calculate. So practice this question. Okay, thank you.